Hello everyone, let's get started on the inferential part of regression and correlation. The first question here under chapter 15 questions says compute the standard error of the estimate and interpret your answer. So standard error of the estimate is denoted by the notation here, just a second, by S sub E, which is the standard error of the estimate. We first obtain the SSE, which is error sum of squares. Now, way up there, we already calculated SSE, so you shouldn't have to recalculate that again. As you're going through the problems, please note down the different quantities that you're calculating. There's a ST, there's a SR, there's a C, the S sub XX, the S sub YY, and so on, S sub XY, and so on. So make a note of that and reuse those values, all right? So SSE we had previously calculated as 75.11. The formula for the S sub E, or the standard error of the estimate, is square root over SSE divided by n minus 2. So plug in the values. N we know for this problem was 8, so 8 minus 2. So square root over 75.11 divided by 6 is approximately 3.538. How do we interpret this? The predicted scores differ from the observed scores on average approximately 3.5382. All right, so that's what the error of estimate means. It's the difference between the predicted scores and the actual observed scores, and this is the average variance or variation. All right, now the next one is a hypothesis test on the slope, inferential study on the slope. Presuming that the assumptions for regression inference are met, decide at the significance, at the significance level alpha equals 0.01, whether the data provides sufficient evidence to conclude that the predictor variable is useful for predicting the response variable. So this is a test on the slope. Whenever we are asked to show whether the predictor variable, that means X variable, is a useful predictor of the Y variable, that means it's an inference on the slope. So the way we state our hypothesis is H sub 0 colon beta sub 1, all right? Not B sub 1, but the population slope is what we are drawing the inference on. So beta sub 1 equal to 0. Now, when the slope is equal to 0, then X has absolutely no role in predicting Y, and that's what the null hypothesis will always state. It'll say predictor variable is not a good predictor of Y. H sub A, or the alternate hypothesis, on the other hand, will state that no, the slope is not equal to 0. It is a useful predictor of Y. All right, now because the alternate hypothesis is a not equal to, therefore it's going to be a two-tailed test, and this is how the alternate hypothesis is always going to be stated, and the only way it's going to be stated. We will not have beta sub 1 less than 0 or greater than 0. That we will do later on when we perform hypothesis tests on the correlation coefficient. All right, but if it is a test of the slope, then it's always going to be not equal to 0. Okay, so let's move on. In step 2, we determined the significance level alpha. So alpha was 0.01, and that's what we have here. Next step is to calculate the test statistic T using this formula: B sub 1 divided by S sub E divided by square root over S sub XX. So B sub 1 was minus 8.456, right? So just take the values that we found previously. S sub E, we just calculated up there. It was 3.538. And S sub XX, you should have noted the value up there when we did all the different calculations. S sub XX, it should have a value if you look up. So you have to take the square root of S sub XX, but the formula for S sub XX is sigma x squared minus sigma x whole squared divided by n. So if you go up all the way, S sub XX, all right, this is the defining formula. Let me just show you where we worked it. S sub XX, we'd worked it here to find SSR, and then also previously we found S sub XX a few times, sub here, all right. To find the slope, we used S sub XX in the denominator. So as you are working through these calculations, please make a note of what the denominator calculation was, and so that you can reuse it. You do not need to recalculate that again, all right? Especially on a test, you will not necessarily get the time to do your calculations over and over again for successive questions, all right? So let's go back to our hypothesis test. All right, so T sub 0 is negative 3.004. Make sure you input the values into your calculators correctly, because if you don't, then you won't get the right answer. You follow the order of operations when punching in the values, and also make sure this sign is a division, all right? Because sometimes I have students ending up multiplying these values. No, keep in mind, even though they are next to each other, this is division, all right? So in fact, if you want, you may want to write it a little bit at a lower level. That reminds you this is a division involved and not multiplication. Anyway, T sub 0 is negative 3.004. You can use any one of these approaches, depending on, of course, what your question asks. If the question says any one, use any one. If the question says use both, then of course you have to show your work for both. But for the critical value approach, the DF calculation is n minus 2 always. So 6, and our alpha was 0.01 divided by 2. It's a two-tailed test, so you have to divide your alpha by 2, 0.005, all right? So on each side, the reject region will be located on each side of the curve for a two-tailed test, and we split our alpha to shade the regions associated with the reject sections, all right? And each side, each reject region has an area of 0.005. So when we find T of 0.005 with DF equals 6, the cutoff values, the critical values are plus minus 3.707. Again, it's important to write the plus minus to your critical values for a two-tailed test, all right? And then you bring your test statistic, which is negative 3.004, and see in which region it falls. So minus 3.004 is actually between negative 3.707 and positive 3.707. So I think the best way, I do not think this is a proper way. We should actually write it as negative 3.707 is less than negative 3.004 is less than positive 3. right? Positive 3.707, right? That tells us that this value, the test statistic value, falls between the two critical regions and therefore falls in the do not reject region. Okay, I think it's better for me to cross that out. So falls in the do not reject region. And if you're using the p-value approach, then you have to find the exact value of p-value and also multiply it by 2 for a two-tail test and compare it with 0.01. If you do not multiply the p-value by 2, then you can compare it with alpha by 2, which is 0.005. All right, but you should get the same result, greater than 0.02 is greater than 0.005. So the outcome is, the decision is do not reject null hypothesis. So at the end, the decision is do not reject null hypothesis, and the interpretation is at the 1% significance level. The data does not provide, right? The data do not provide sufficient evidence to conclude that X, the predictor variable, is an useful predictor of scores. Therefore, study time is not useful to predict scores. All right. So if it is do not reject, then the data do not provide sufficient evidence to conclude that whatever the alternate hypothesis is trying to state, right? Okay, for the next question, we have to find a confidence interval of okay, just a second. The next part of inferential studies on the slope is to find the confidence interval, right? So we have here, just a second, let me pull up my pen. It says find and interpret a confidence interval at the 99% confidence level for the slope of the population regression line that relates the response variable to the predictor variable. So we did the hypothesis test previously. Now we have to find the confidence interval within which the population slope may lie. All right, again, the overall process is the same as finding any other confidence interval, and we will see in the formula we will have already found most of the values that we need to plug into the equation when we were doing the hypothesis test. So let's quickly go over this. Step 1 is to find T of alpha by 2 with the DF n minus 2. So for 99% confidence interval, our alpha will be 0.01, therefore alpha by 2 will be 0.005, and the DF is 6. So we already found this value, T of alpha by 2, 3.707, when we were doing our hypothesis test using the critical value approach. So you can reuse that value. Then step 2, it says find the endpoints of the confidence interval for beta sub 1 using this formula. So take your sample slope from your sample regression equation, plus minus T of alpha by 2 times S sub E, also we found when we were performing our hypothesis test, divided by square root over S sub XX, which we also found during our hypothesis test. So plug in the appropriate values. Now make sure that you do your calculations right especially when plugging in the values, punching in the values into your calculators. Follow the order of operations, and when we complete the calculations, we get an interval ranging from negative 1.890 to positive 0.198. Now, over here, we see one end is negative, the other end is positive. That means 0 falls within this interval, which would mean that the slope could have a value of 0, which makes the x variable, the predictor variable, useless for the response variable. And that's exactly what the hypothesis test said. There's not enough evidence to conclude that x variable is an useful predictor. All right, so the confidence interval findings agree with the decisions from the hypothesis test, right? So this completes the inferential study on the slope. We completed a hypothesis test as well as the confidence interval. Now, before I proceed to the next part of the question, I would like to go back to the confidence interval for the slope and put in an interpretation. So to complete this question, we should, of course, interpret the confidence interval. We found saying that we can be 99% confident that the slope of the population regression equation, the slope beta sub 1 of the population regression equation, will be contained in the interval population regression equation will be contained in the interval so state your interval negative 1.890 to 0.198, and also say since the interval contains a 0, right, the slope is not an useful predictor. Well, let me fix this here. It's not the slope that's not the useful predictor. The x variable is not an useful predictor for y. All right. So you have to finish your confidence interval question with an interpretation. All right. Now the next part of the question says determine a point estimate for the mean test score of all students who study for 15 hours. So what we have to do here is plug in 15 for x and find the y value, what the expected score would be from the sample regression equation by plugging in 15 for x, and what we get is 82.183. So the score that we can expect if somebody studies for 15 hours would be 82.183 based on the sample regression equation. Now, given this finding here, the following question says, find a 99% confidence interval for the mean test score of all students who study for 15 hours. So now we have to find a 99% confidence interval, which would contain a mean score for all students or all x values of 15 hours. So again, For a 99% CI, the alpha is 0.01, alpha by 2 therefore is 0.005. It's the same df6, so we have T of alpha by 2 is 3.707. All right, so we can reuse that that information. Next is to compute the point estimate, which we already did previously. The point estimate would be whatever the y value is when we plugged in 15 into the regression equation. It was 82 point something. This part we already found in the question up here. All right, so you need not repeat that as long as you know what the y hat sub p value is when x is 15. And then this is the formula to use for the confidence interval. Make sure you plug in the right values. Y hat sub p is going to be your point estimate, and to it we will add or subtract whatever the margin of error is from this part of the formula. All right, again, so make sure you plug in your values correctly. X bar here is the mean of all the x values. All right, so make sure you understand that and calculate that correctly. S sub xx should already have been calculated previously from a previous part of the question. Again, you have to make a note of that, and so would S sub e would already be calculated previously. All right, so here's the calculation. The margin of error was plus minus 4.6537, and this is what we have for the mean of all scores when the x value is 15. All right, so we can be 99% confident that the mean test score of students who study 15 hours is going to be anywhere between 77.53 to 86.84 perhaps, right? So that answers the confidence interval question. And then there is a prediction interval as well, a 99% prediction interval. It's the same process, so I'm not going to spend too much time on it. However, the formula is slightly different from the one we used before. We have 1 plus under the radical. All right, it's 1 plus 1 divided by n plus x sub p minus x bar whole square divided by s sub xx. So here is the complete calculation, and we obtain a margin of error of 13.9172, and the confidence interval evaluates to 68.2656 to 96.010. And then we have the interpretation up here. We can be 99% confident that a randomly selected student who studies 15 hours will have a test score between this interval given here. So state your interval, right? Now the last question on chapter 15 is on a hypothesis test for the correlation coefficient, which is R, correct? So let me get my pen out here. So correlation coefficient is denoted by the letter R when we talk about the sample regression equation. However, when we refer to the population correlation coefficient, we use the Greek letter rho, which is like an italicized P. All right, so the question says here, at the 1% significance level, do the data provide sufficient evidence to conclude that a negative linear correlation exists between study time and test score for the students? So it says negative linear correlation. So negative linear makes it a left-tailed test. So the way we state our hypothesis is H sub 0, the null hypothesis, will be rho equal to 0. So null hypothesis is going to state that there's no correlation between X and Y values, the study time and test score. And the alternate hypothesis states that rho is less than 0, a negative linear correlation is what the question is asking us to test. Therefore, rho is less than 0, left tail test. Now determine the significance level. We are testing at 1% significance level. So alpha is 0.01 and we do not need to split it because this is a one-tailed left tail test. DF, however, is n-2, which is a 6. The formula to calculate the test statistic is R, so the sample correlation coefficient value divided by square root over 1 minus R squared. So again, R squared is coefficient of determination. Keep that in mind, divided by n-2. Again, plug in your values correctly and also enter them correctly as well on your calculators. And once you get the right value for the test statistic, in this case it's negative 3.003, we can now proceed to the performing the test using the different approaches. For the critical value approach, the reject region is going to be on the left hand side. The do not reject region is going to be on the other side, and the cutoff, that is the critical value of T of 0.01 with DF6 is negative 3.143. Now, if you're using your table, then you will come up with a positive value. The table only gives positive values, but because it's on the left hand side, because it's a left tail test, it's going to be a negative. So remember to put your negative sign, right? Keeping in mind that you're performing a left tail test. And then we bring our test statistic value of negative 3.003. It falls in the do not reject region. It's going to be somewhere to the left of, to the right of the critical value. This is the critical value. It's going to be somewhere to the right because negative 3.003 is greater than, right? Negative 3.003 is greater than negative 3.143. It falls in the do not reject region. Therefore, the decision should be do not reject. All right. Now, if you're using the p-value approach, if you're using a graphing calculator, you should get the exact p-value. If you're using the table, it'll be an estimated value, and I use the table here, and the p-value was a value between 0.010 and 0.025 when we compare the p-value with alpha, which is 0.01, right? 0.01. It's definitely going to be greater than 0.01. Therefore, the decision is going to be do not reject. All right. And then finally, we make the decision. It's do not reject. So decision is do not reject. Null hypothesis. Do not reject null hypothesis. And therefore, your interpretation is at the 1% significance level. The data do not provide sufficient evidence. The data do not provide sufficient evidence to conclude that what was it? Just use the wording from the question. To conclude that a negative linear correlation exists between study time and test score for the students. Okay, do not provide sufficient evidence to conclude to conclude that a negative linear correlation exists between, just take the wording from the question. All right, between study time and score. Okay, so that completes the solution set for all the questions in your test 2 review project. But you're supposed to work on all the questions yourselves. Make sure you can do it on your own, and then just as a guide, go through these solutions to make sure you're on the right track. All right?